So let us now explore Amazon Redshift, which is another in the database category, but it is not actually a database. It is a columnar relational data warehouse. It is a data warehouse where a large chunk of data, larger than the database, is usually kept and stored. Let me tell you a simple example for those who don't know the difference between database and data warehouse, which information is kept in database and which is kept in data warehouse. You may have booked a railway ticket, train ticket, metro ticket, or aeroplane ticket online. So think from the perspective of the airline agency. When somebody or a large number of people book their tickets for a particular flight, suppose let's say British Airways carries over 1000 flights per day from different locations across the world. So for each flight, almost 1000 persons or 500 people, for example 500 people, book their tickets online. They book ticket in advance, usually 1 or 2 months ago. For example, they booked a flight ticket for 22nd October 2018. Till 22nd October, the information of the people who will travel through a flight will be kept in a database. When the data is hugely required, you can perform query, validation, and other forms of data operations. After 22nd of October, when the flight has landed those people, the data is not actually deleted, but it is shifted to a data warehouse. A data which is not being used right now, but can be used in a near future for any sort of thing. For example, if the plane crashes, so there is a problem for insurance claims. So how can the airlines industry verifies who were boarding on the flight? If they have to maintain everything on a database, the database will soon degrade on, because there are 1000 flights every day, and they have to list details of 500 passengers each day. Such a huge challenge to a database. So all the data which is not in current use is stored in the data warehouse. So Redshift is a typical solution. So now let us explore what is Redshift. Redshift is a columnar relational data warehouse. It is massively parallel. It can perform parallel processing. The data that can be stored here is of the scale of petabytes. The charges for your storage is up to $1000 per terabyte per year. So it is cheap as compared to other solutions. You can use existing business intelligence tools like Tableau and other tools along with Redshift. It is based on PostgreSQL, so it is relational and you can perform SQL queries and operations. So this is a simple architecture for Redshift. It has a leader node, the compute node, and everything is mirrored. The leader node manages the compute nodes who perform columnar storage and execute queries in parallel slices, either via S3 or other sort of storage. The leader node performed is based on Postgres, stores metadata about compute nodes. It can communicate with clients using business intelligence tools and other things. It helps coordinate query execution. So this is a simple scenario where the difference between traditional data warehouse and Amazon Redshift. In traditional data warehouse, you require a large number of team to manage your data warehouse. You need to maintain physical facility, network engineers, database administrators, and other sort of developers. But with Redshift, you don't need to worry about all sort of things. Everything is in cloud and managed by the cloud vendor. You just need to upload your data or download or retrieve or just forget about it data. Redshift work with existing business intelligence tools. The tools could be Activate, Burst, Jaspersoft, JReport, MicroStrategy, Pervasive, Tableau, and more. They can interact with Amazon Redshift using JDBC or ODBC bridge, ODBC JDBC driver for languages like Java, C, and other. Connect using drivers from PostgreSQL and other things. Shift and S3. For example, we have currently a data corporate data center where our a huge chunk of corporate data is stored in data warehouse, and suddenly our company start feeling that we should migrate our data on the cloud. So how we can do so? We will define the schema conversion tool, establish certain migration agents. Then the migration agents pass our data to Amazon S3 bucket, that is object storage, and after your data is passed to S3 bucket, it is shifted to Redshift, Amazon Redshift, the data warehouse. We have explored various solutions. When we copy or remove our data directly from any outside vendors, outside of warehouses and traditional storage, we firstly actually upload our data to S3 bucket, simple storage service. Then we can copy that data to Redshift or other form of data, which is quite simple and easy to manage. So this is another case how Redshift works. Uh, a person can log in with AWS console, check schema conversion tool, perform SQL operations based on SQL client hosted on internet. The internet gateway goes to availability zone for RDS, Redshift, or data migration service. For example, if you are migrating your data from RDS for Oracle or for MySQL or for any other thing, you can migrate your data from RDS to Redshift using database migration service of the Amazon. It simply migrates your data. Or in the reverse process, you can migrate your data from Redshift to RDS or other form of database. AWS Redshift for retrieval and collaboration, we can use it for retrieval and collaboration also because it is fast, fully managed, petabyte scaled, making it simple and cost effective to efficiently analyze all your data using your existing BI tools. It is simple. You can also generate custom reports, uh, do analysis work using any form of analysis tools available on cloud. This is simple architecture of Redshift Spectrum. A person using any business intelligence tool could log in or could enter could uh, create a request using JDBC or DBC bridge from client application, goes to the leader node. The leader node uh, controls or divide the task to other nodes. The other nodes goes to independent scaling the spectrums. They perform certain tasks, and the task is reflected to S3, and from S3 it is again fetched back and it is done, where we use redshift scaling and independent scaling. We could skip independent scaling stage or perform directly redshift scaling. We can scale up our data. So try creating your own data warehouse solution with Redshift just for fun. Or if you are building an advanced application, you can build a solution based on this.